welcome to another Cassandra.Lunch. Give me 1 second. I'm going to go ahead and get the screen shared. Could you just give me a thumbs up if you can see the screen?
We can see it.
Okay, great. Yeah, welcome to another Cassandra.Lunch, Cassandra.Lunch 129. It's kind of amazing. More than 2 years? Yeah, definitely more than 2 years. 3 years, I think. Today we're going to be talking about some of the new features in Cassandra 4.1. 4.1 was released in December of 2022, like December 15th. 4.0 was released the year before. And before 4.0, there was a big gap between major releases. There was 3.11, and then there was a big contention in the community as far as like, should we release 4? And so now there's a better cadence, although there's discussion on the mailing list about what took 4.1 so long to come out, because 4.0 came out in like April or May, but 4.1 came out in December. And it's really interesting if you want to see how great software is created. I was talking to somebody else earlier this week that some of the most advanced software is open source, and you just go and look at the code, but also just paying attention to the mailing list, what people are discussing, how they're prioritizing bugs and features, and how they're solving some difficult problems. It's really fascinating. Akwi and I co-organized this meetup. Thanks, Akwi. Akwi's lost his voice today, so I'm filling in as the MC. We always are looking for sponsors. We're part of a data community DC, which is a large group of data practitioners, and we like diversity. And so if you're in an underrepresented group, we'd love to have you speak. You can find out more at datacommunitydc.org. We cover things in the Cassandra ecosystem: Cassandra, Apache Cassandra, data stacks, managed key spaces, other things that talk to Cassandra like Kafka and Spark. If you're new to the group or just want to say hi, just put it in the YouTube chat. And if you have questions, you can go ahead and ask in the YouTube chat, and then Akwi will relay them onto me in Zoom chat. And then Akwi, if I don't answer, just unmute and let me know there's a question. We at Anant, we're one of the sponsors of this group. We have a few other co-sponsors, and then we have our organizational sponsors for Data Community DC. If you're interested in sponsoring this group or Data Community DC, you can actually reach out to me. I'm the business development director of the organization. It's a nonprofit. Do you have any announcements? If you're looking for a job, drop your link to your portfolio. If you're offering a job, drop a link to the job requirement. If you're offering anything, just feel free to do that. We have ongoing events every week: Data Engineers Lunch, Cassandra.Lunch. Data Engineers Lunch is on Mondays, Cassandra.Lunch is on Thursdays. We're actually doing something different next week. It's not a Cassandra event, but it's going to lead up to working with Cassandra, which is how to automate your job in business with ChatGPT. You can find out more at anant.us/events. A lot of our videos are online. You can just Google us. If you just look for Cassandra.Lunch, you'll find an index on GitHub. There's a README of all the talks, the blog posts related to it, also on YouTube. We're continuing to work on Cassandra.Link, our knowledge base of all things Cassandra. And just a reminder, before it goes away, there's a runbook related to Cassandra settings, and then a bit about Gigabyte on our website. I'm just going to go ahead and go straight into the talk. Okay. Right. Oops. don't want to do that. I'm just trying to play the slideshow, dude. There we go. All right, Kui, if you could just give me a verbal, it's coming up okay?
Yep, we can see it.
All right, great, thank you. So what's new in Apache Cassandra 4.1? Talk about what's in 4.1 and also what's coming up in the pipeline. Just the big shout out here for everybody to understand about Apache community is that, you know, give them a lot of credit for creating a really amazing software that a lot of the world uses, especially big companies. But folks that have been delaying upgrading, like, it's time to upgrade, because as the new major versions come out, the community is only going to support 2 major versions before that, and even DataStax, which is, you know, one of the main committers, they're going to stop supporting their major versions. So, for example, 6.8 is based on 4.1 and some features that are going to be in Cassandra 5. You know, they don't want people using 6.0 because there's a 6.0, 6.7, 6.8. The 2 major versions is not like 6 and 7. Major version is 4.0, 4.1. So after 4.2 comes out, even 4.0 will go to the not the chopping block. It's to keep people using current software. And as an open source community, you can't support old software indefinitely. There are upgrade guides, and, you know, if you need help, you can go to the Cassandra mailing list and you can get information. You can go to DataStax and find information. If you need help, we can also help you at Anant. What do we do at Anant? We help platform owners build great platforms that reach a global customer base. So that customer base wants everything right now, all at once. We design with our playbook, we build with our framework, and we manage platforms with our approach so that they can focus on thinking and growing big. And so we tend to work with Cassandra Technologies, Spark Technologies. We work with a lot of brands you're aware of that are in your everyday life. Today, I'm going to talk about kind of like 2 audiences where the features will resonate. One is the developer user, and the other is the operator or admin. And both of these are important to architects. So, you know, better development and user experience. I can say that the top 3, the SQL improvements, STEP stands for Cassandra Enhancement Proposal. It's not actually a ticket because there may be several JIRA tickets associated with that proposal. Config. These 3 are in 4.1. Now, this 5.0, I'll get to in a second. So the biggest thing is, how does it impact the developer that is using Cassandra as a to put data in and get data out, right? So one major thing is being able to do time range group bys. So if you have for example, a column in which you have, you know, the date or the time, and you want to do a group by based on a particular range, you can now do that. Obviously in one partition, right? You don't want to do group bys across partitions. The lightweight transactions, they now allow contains, and it contains key if you have a collection, set list or map. And so, for example, you know, I have sessions and I want to set it into a draft mode where the session ID, given a particular primary key, if the preference contains a key called allow draft. And this is important because before you could only do it on columns, right? Not necessarily collections inside a column. And then there are alter statements across the board, but definitely in the table or column, now you can do if exists and if not exists, which is useful. So, and there's tons of other improvements. Like if you look at the news.txt, which I'll link in the last slide here in this deck, which we'll publish, you look for CQL and it's like 100 different changes, but these are the major ones. The other major change for users is that Paxos, which is the protocol used for consensus in Cassandra, it's been improved so it does less round trips. And for basic durable writes, meaning to make sure it goes to all of the replicas, there's only
I think I got disconnected. Is my audio back? Akwi?
Yep, you're back.
Okay, I don't know what happened. I think I called in and I was expecting the phone to be more resilient than the internet here. So Paxos is what basically keeps consensus or helps Cassandra keep consensus and make sure that the nodes are talking to each other. If you're doing like a linearized write where it goes to all of the nodes, then it only needs one round trip. Before it needed several round trips. So that's a big improvement. I know other distributed databases, they're now starting to use Raft as a protocol. That was a discussion before, but Paxos is embedded into Cassandra. So getting it improved, making it work better just helps everybody out. The configuration has, and I can pull it up in a second, but the configuration improvements are more about understandability and keeping consistency in terms of, like, if it's a metric, right, having one format rather than being able to do several different formats. And actually, I'm going to bring it up. Let's see. Right, so essentially, we had we had sometimes confusing parameters. Now they are very clear. So there's the what is it, what the object is, what is the the verb essentially, and then what is the metric for it, and that basically allows people to understand it much better, right? So like key cache, save period, and then if it has a particular increment. So you can read more about it. And then the exciting part about users and developers of Cassandra, I think that's big news, is coming up in 5.0 are general purpose transactions, which is consistency, right? People say, oh, Cassandra is not consistent. Well, technically it's tunable in terms of you can say, I want consistency all, or I want consistency one. Nobody does that, and that's durability that is tunable. Now, in general purpose transactions, you can do multiple things, and it can either finish it or it can roll back, which is more of a feature in relational database system. And so there's a paper that was released by Apple, which the Cassandra community is implementing inside code here. And actually, if you take a look at what that example looks like, it's kind of cool. Patrick McFadden has kind of been telling me, he told me about it, and then he was doing some examples. But essentially, you can have this badge where it will either do it or not do it, right? And then you can use it eventually in the future for other types of operations as well, right? So they took some ideas from other databases, like let's say you go by Dynamo, and they brought it back. So good improvement overall. I think it'll take care of some issues people have with consistency. And then the other big change in 5.0 that I'm getting excited for is the storage attached index. I've been using storage attached index in DataStax and in DataStax Astra for a while. It makes data modeling a lot easier. There was a talk by Vel a couple of weeks ago about how he was using storage attached index. And after you start using storage attached index, you don't want to go back. It's like, it just makes it a lot easier to create applications very quickly. And that way you don't have to write data twice because it's taking care of that indexing for you. The next kind of major user, again, the admins, there's two aspects, which is the operability of the cluster, and then also the security, which is related to operability. I used to do a lot of operations, and I still kind of keep tabs in the operations world, especially from DevOps and infrastructure. So although I don't necessarily set up clusters right now, or I'm generally involved in tuning them. It's important to see what's now coming down the pipeline, or what is in place now that will resolve so many issues we had. So for example, SEP 10 is about how to do better testing and simulations for, because Cassandra's, I think it's a relatively simple system, right? You have these nodes, they use the same software, same binaries, there's different config files, and then it magically just comes up and manages these messages between nodes and data centers, and it just works. But it's complicated in terms of why it would go down. There's so many different reasons why it would go down. So there's work to basically make it better, to make better simulations in the testing phase, so that next new releases of Cassandra are better tested before they get out to the public. Now, guardrails were brought in by DataStax as one of the first SEP proposals, and there's so many anti-patterns in how developers use Cassandra that finally they decided, let's just put some guardrails, meaning we're just going to tell people that they're going against the guardrail, or let's not let them do anything beyond a particular threshold. And so an example, and there's a blog post, but there's also a SEP page about it. So for example, right, how many tables can you have in a cluster, right? So the recommendation is like 100 to 200 tables. I know clusters that had 700 tables, right? So people didn't know any better, right? So in this case, this is saying -1 just means that it's not going to warn you. Now, if you said 100 here for warning and then 200 here, it would not allow people to create new tables on the cluster. And so these are system-wide, right? These guardrails are system-wide. They're not at the kind of the table or key space level. Another one, allow filtering, right? So allow filtering should not be done unless it's on a particular partition. So we can disable that. Otherwise, it can bring down the cluster. The number of partition keys in a select. So the recommendation is you do select statements which are on one partition, and you can do queries on that partition, get certain rows. So if you have queries that are getting many partitions from whatever method, it says let's not let people pull more than, let's say, 5 partitions or more than 10 partitions, because it puts a strain on the coordinator node, right? Anyways, there's more to come. I think there'll be a better usability of this, but I wouldn't say that you start using these guardrails today, because it could make some of your developers really unhappy. So if you're going to implement guardrails, put them in a test cluster and then get people to try their software and then work your way back. I, for example, wish I had this guardrail for number of tables, the number of tombstones, the number of cells that are pulled, because people were noticing issues as the cluster grew, as their use cases grew, but then nobody was paying attention to like the table stats or the log entries for why these compactions are taking longer, or why the logs are showing so many warnings. With this properly implemented guardrails, the warning threshold and a fail threshold, you can put in into your log or whatever you use to aggregate your log, that hey, if we start hitting these warnings or these failures, let's alert people that hey, they need to change their code essentially, or they need to change their data model. This right here is a very edge case use case, deny listing. So for example, if we know there's a massive partition, for whatever reason, it's huge. Like I was working with a customer a couple weeks ago, identifying a big partition, and it was like a gigabyte. And anytime it was pulled, it would put strain on the cluster. So deny listing can basically allow the administrator to, deny users to select that partition. It will just say, hey, I'm not allowed to give you that partition, it's too big, or for whatever reason, right? And that's useful in, again, a very edge case. SS table identifiers, again, it comes down to the disk level. Sometimes it's hard to see which ones are new SS tables, older generation, newer generation. And what they've done is they've got a format for the name so that you can know, right? Like there's a date part, there's a time part, there's this kind of nano part, which I'm not sure about. But basically, you will know that this is all part of the same date. This is part of the different time. This is part of a different kind of generation, nano, essentially. And over time, these things get compacted, but you'll know that this compaction was done at these SS tables were all created on the same date. And when it gets compacted, if there are several compacted SS tables, you'll also know that. Kind of esoteric, but when it comes down to backup, restore, cleaning out, reclaiming this space, and knowing how these SS tables are, where they're at, when it were created, makes it a lot easier. Coming back to, and then finally the pluggable mem tables and schema management. I'll explain why that's important. There's actually a pluggable SS table proposal by Instacluster a while ago. I hope that comes back into the Cassandra world at some point. But in pluggable mem tables, there's improvements for how, when you make writes to Cassandra, you're writing to the mem table, which is an in-memory representation of the partition and the commit log. And then when the mem tables are flushed, essentially everything in memory and what's in the commit log, they get reconciled and they get put into SS tables. Up until that point, it's just in memory or in the commit log, right? Yeah, that's great. That's what allows Cassandra to be heavy write, heavy read, and not have to wait for that data. It's just there in memory, available to you. But when you have partitions that grow, anytime you look for even one row, that partition needs to be pulled up from SS tables into the mem table for you to be able to basically get it, right? It needs to be in memory for it to be able to transport it over the network. And one of the benefits of having pluggable mem tables is that people can implement different ways of doing mem tables. So, for example, in this case, I think this is an Intel representation, or sorry, an Intel plugin, which is that we can have a mem table sharded in memory that allows big partitions essentially to be able to be used. Now, I don't think that's necessarily going to make the data model better. In fact, people will continue making worse data models, but this allows that to be more efficient, excuse me. And there's definitely these are kind of the different ways the operations per second improve based on just the default, and then what are some of the new ones that are coming out, right? So persistent memory mem table, right? And then there's a tree-based, trie-based mem table as well. And more can come. People can then produce their own mem table and make that available. The other pluggability, which is schema management, at first when I heard about it, I didn't see the use case, but as I read about it, it really helps. For example, when you want to do have a schema for a very large cluster, for example, in Kubernetes, for example, you can have that schema data, the system schema key space. You can have that information stored in etcd. Etcd replicates very quickly, right? Whereas in Cassandra, it has to be done serially, and that schema has to be applied to 100 nodes, to 1,000 nodes. And has to percolate through the whole system, right? So having it in something else allows for better performance and makes it a little bit more cloud native. And this is not just etcd. You can use something else if you want, right? So right now there's two potentials, right? Cassandra itself, or you can use etcd. Security is always a concern. I think I'd covered security before. A lot of folks on this webinar have covered different aspects of security. Couple of improvements. So one is when you use CQLSH, it's a Python program, right? And generally, there's things that are in Cassandra that allow you to authenticate to get to CQLSH. Well, with this plugin support, you can connect to other systems. Let's say you wanted to log in using Okta, LDAP, or Microsoft Active Directory. As long as you have a Python class, essentially, that can provide the credentials, you can plug it in. And this also makes it easier to not be 100% rely on just CQLSH, CQLSH-RC, which is a file that's in the file system that has authentication details, right? You can now say, get this authentication detail from Active Directory or from somewhere else, from Kerberos, and the user is authenticated through those systems, and it's pulled in through the Python layer inside CQLSH, and then you're authenticated without having to like put in your password, right? And then on the SSL part, there's a few ways to use SSL in Cassandra. One is client to node or client to server, encryption, and then there's internode encryption. And so far, that's done with some files, key store, trust store in the system. But enterprises have different places where these certificates could be. HashiCorp Vault, Amazon, key management. Azure has a key management as well. And so having this ability to connect to other providers makes it easier to put Cassandra in a enterprise where then, you don't have to necessarily distribute keys to 100 nodes. You can just say, here's where my keys are, and it would grab them and it would work, right? So the pluggability, again, is at the Java layer. It's if you wanted to connect to your own key store, for example, or where these things are, and you implement something that connects into the SSL context. Where is it? Yeah, so for example, right, custom key management, HashiCorp Vault, Amazon Key Spaces, Amazon Key Management Suite. All of these are potential places you can have your keys. And these things people have been requesting since I got into Cassandra about 7-8 years ago. So coming into the 2023, I'm glad it's there. I wish it was there earlier. Hash passwords. This is another thing kind of related to the CQLSH-RC. There are, when you set up a user or role in Cassandra in CQL, you have to say, here's the username, here's the password, unless you use an authentication provider. And what pre-hashed passwords let you do is it allows you to pre-hash the password, get a hash, and that's how you create the user. And then when you authenticate, you're using what your password really is. And then also in configurations, right, you can use the hash password so that people don't know necessarily what your password is. It's because it's easier from an automation perspective, just have hashes around. And some of this stuff, actually, no tool backup and restore really should be in the operability. I guess I forgot to move it there, but there are improvements in how we grant, revoke, and list permissions at the key space, at the table level. For example, before you could give all permissions to a key space and then everything underneath it, like user-defined functions, user-defined aggregates, user-defined tables, types, etc. But you could say just give permissions on tables, or just give permissions on the user-defined types. And then system tables have been continuing to improve, I'd say, since 3.11. But recently there have been system views. They're not actual tables, but they look like tables for like top partitions. You can literally say select top partitions. Like in Linux, you could say, show me the top, what's running, what's taking up memory. Top partitions will tell you in real time what the big partitions are. And that's useful, not only like going to a cluster and looking up that information, but you can stream that information to other systems using JMX, like into Prometheus or into Elastic, and be able to see the trends. Nope, we've already been through that. So key takeaways. Key takeaways. It's time to upgrade. You're going to have better operability, better security, a better extendability. That's actually a big part of our framework in our playbook. Things should be distributed, real-time, extendable, automatable, and monitored and manageable, and Dream. So the more extendability that gets put into Cassandra, the better from my perspective. And then there's a better developer experience. So, you know, it's not bringing joins yet into Cassandra, although that could be something in the future. It's not letting people do arbitrary wares, but by the time we're in Cassandra 5 with SAIs, and the other improvements in CQL, SH, and CQL, it just makes it a lot easier for developers to get into this awesome database. That's all I had for you guys. I think it was just time to get people up to date on what's out there. The resources that are part of this are going to be on the PDF. In the Google GitHub. We'll have a link to the PDF and the Google. I keep saying Google SlideShare. I hate that software too, by the way. SlideShare in our blog. We have our Cassandra.Link. In fact, I've just made sure that these were added to Cassandra.Link. So you can just go to Cassandra.Link and look for these things. And I'm happy to announce that we're collaborating with several companies, including DataStax and Constantia. We want other people to come and collaborate to relaunch Planet Cassandra, which was actually the main inspiration for Cassandra.Link. And it's coming. So if you have any feedback or if you want to get involved, reach out to us on with a YouTube comment or just find us online and send a note. We're happy to have you. And there were some questions, I think. No. Okay, excellent. No questions. Well, folks, thank you for joining. Have a wonderful rest of the week, and we'll see you next time. Take care.